Mathematics, Edexcel IAL, Mechanics, M1, October 2023 paper will be discussed in this video. Okay, this is the first question, M1, October 2023 paper. This diagram is given. Here is a uniform rod. Uniform rod means the center of mass will be exactly at the center of the rod. That means it will be at a distance of 3 meters from A. The weight of the rod is also given. The weight of the rod is given as 24 Newton. So the weight will act here. That will be 24 Newton. Okay, also the question says that it's at rest, equilibrium. The tension at D, that these are the two ropes used to hang the rod. The tension at C, the rope which is attached to C, is double the tension of this one. So if I take this is T, this must be 2T. Okay, the first part, find the tension of the rope. Okay, you know, if the rope, if anything is at rest, equilibrium, two conditions must be satisfied. Remember that. O level also you had that one. The resultant force must be equal to 0. That means if you resolve all the forces to any direction, in that direction the resultant force or the total force must be 0. Otherwise, in that direction, if there is a non-zero resultant force, what will happen? The object will accelerate in that direction. It will move, is it? So in any direction, the resultant force must be 0. Here only the forces acting on it are upward direction tension on the ropes and the downward 24. So in vertical direction, resultant force must be equal to 0, the first condition. Second condition, if you take moment about any point, the total moment must be equal to 0. Or we can say, when you take moment about any point, the total clockwise moment equal to total anti-clockwise moment. Either way we can handle total clockwise moment equal total anti-clockwise moment about any point, we can say, or the total moment, that is net moment, must be equal to 0. Okay, first part, find the tension. I'll just use resultant force equal to 0. So if I take resultant force equal to 0 vertically, T plus 2T plus T minus 24 equals 0. So 3T equal 24 Newton. T will be equal to 8 Newton. Okay, second part, they asked to find the distance x. I can take moment about any point. Any point could be taken as a pivot. Just no reason, I'm just taking A as a pivot. You know moment means force into perpendicular distance to the line of action of force. You had it in IGCSE O level also. So we take moment about A. I'm taking anti-clockwise direction, positive. Any direction I can take positive, no reason. I'm just taking anti-clockwise direction. Moment positive means clockwise direction I had to write negative. Total moment equal to 0. So that means 2T into x. The distance of T from A is x minus 24 into 3. The center of mass from A is 3 because it's a uniform rod, plus T into the distance of T from here, x plus 2 or 2 plus x. Either way we can write equal to 0. Solve it. That is 2tx minus 72 plus 2t plus tx equals 0. Otherwise I can substitute tension here. That's easy. Substitute tension, I already found it. So tension equal 8, 8 into 2, 16x. That's easy. 16x minus 72 plus 8 into 2, 16. 8 into x plus 8x equal to 0. So that's going to be 8x plus 16x, 24x equal to minus 72 plus 56 minus 56, take to the other side, it will become 56. So x is going to be 56 divided by 24, 7 by 3 meters, or if you give it in decimal, 2.33 meters. That's the answer for the first part. Even O-level knowledge is enough to answer this question. Okay, second question based on motion graph, that is acceleration time graph. Whenever you get a question related to motion graph, you must know the properties of the graph. Here this is acceleration time graph. So what's the property of the acceleration time graph. It has only one property, that is area covered by the graph and the time axis gives the change in velocity. So the area here, two different areas are there. If I take this A1, this is A2, the area A1. When we find the area, we need to consider the sign of the acceleration also. So the area A1 is the change in velocity during 0 to 4 seconds. Change in velocity or speed, either way I can say, during 0 to 4 seconds, that is going to be minus 0.5 into 4, that is minus 2.0 meter per second. Same way A2, change in velocity during 10 seconds to 20 seconds. So that's going to be 1.2 into 20 minus 10 is 10. So that's going to be 12 meter per second. Okay, we have to include the sign. Okay, 0 to, I'll go to, yeah. So that is the only one property regarding or related to acceleration time graph. Area gives the change in velocity. So the question says, two fixed points A and B are on a straight horizontal road. The acceleration time graph is given for the motion from A to B. At time t equals 0, the car passes through A with a speed 8 meter per second. So if I draw a block diagram, so this is A. So there the velocity or speed of the car is 8 meter per second. So that is 8 meter per second at time t equals 0 initially. So when it is here at this time, the speed is 8 meter per second. Then at time t equal 20 second, car passes B with a speed v meter per second. So at B, that is the end of the graph shows, at that time it passes at v meter per second. This is at time t equal 20 second. Okay, so the question is, show that v equal 18. So the final speed I should show 18 meter per second. That's a question, right? So at time 4 second, so this is t equal 0, t equal 20, t equal 4 second, I'll consider the speed as v1. And at 10 seconds, v2. This we can take initial speed u, that is u is 8 meter per second, it's given there. Okay, the question is find the final speed at 20 seconds. So that's a question, first part. So A part, when I find the area of A1, that gives the change in velocity. Change in velocity means final velocity minus initial velocity. So during 0 to 4 seconds, if I consider, that is final velocity v1 minus u is equal to area A1. v1 is, I need to find, u is 8 equal minus 2.02, doesn't matter. So v1 is going to be 6 meter per second. So the speed at 4 seconds or velocity at 4 seconds is 6 meter per second. Now during the time 4 to 10, there is no graph. You can see the acceleration equals 0. So v2 also the same velocity, 6 meter per second. The question is about B. So we'll consider the time during last 10 seconds. During 10 seconds to 20 seconds when I consider, change in velocity is the area, that is v minus v2 equal the area A2. So v minus v2 is 6, area A2 I found it 12. So v is going to be 18 meter per second. That's the question they asked to show that. Okay. Okay, so B part, they asked to sketch the speed time graph. Speed time graph is always on the positive axis. If it is a velocity time graph, it could be on the negative side also, because velocity is a vector. Speed is a scalar quantity, but anyway, they asked to sketch the speed time graph. Okay, we'll by using the calculations we made, we'll draw the speed time graph or sketch the speed time graph. Okay, when t equals 0, the curve was moving at 8 meter per second. That's given, 8 meter per second, right? We'll put the 8 here. Then it's uniformly decelerating. How do I know deceleration? Because the speed is given positive, this is negative, so we know that it's decelerating until the velocity reaches 6 meter per second. It's a uniform deceleration because line is horizontal and constant gradient. So the speed should decrease along a straight line. So 4 seconds, it comes to 6, you already calculated. Then from 4 to 10, it remains constant, no acceleration. Then from 10 to 20, again it's accelerating, constant acceleration, and we found that final velocity is 18, so it's go to 18. This is 18. That's the graph. Simple graph, is it? So anyway, eye level, this should be steeper because acceleration is more. This is little slant because 0.5, this is 1.2. Right. C part, find the distance AB. Okay, you know that property of the speed time graph. Area covered by the graph and the time axis gives the distance. So distance AB, we need to find it. So we need to find the area covered by the graph and the time axis. So we need to find this area, the whole area under this graph. Is it this area? So we don't have any equation for the whole graph. Part by part we'll do it. This is a trapezium. So area of a trapezium half into addition of the parallel side into perpendicular distance between the parallel sides. So that is half into addition of the parallel side means 8 plus 6 into perpendicular distance 4. This is rectangle, so that is 6 into 10 minus 4 again 6. 10 minus 4, 6, 6 into 6 is a rectangle. This is again a trapezium, half into addition of the parallel side, this is 6 plus 18 into 20 minus 10 is 10. Okay, solve it, you will get the distance between A and B, that will be 184 meter. That's the question number 2. Okay, question number 3. A hammer is used to hit a tent peg into soft ground. The hammer has a mass of 1.8 kilogram and the tent peg has a mass of 0.2 kilogram. Hammer and tent peg are both modeled as particles and the impact is modeled as a direct collision. Immediately before the impact, the tent peg is stationary and the hammer is moving vertically downwards with a speed of 10 meter per second. Okay, just simple, we can draw a diagram. So this is the tent peg. Just anyway, they asked to treat it as particles, but I'll draw this tent peg. So it was at rest, initially it was at rest, so u1 equal to 0, but the hammer, just before collision, the hammer is moving downwards at a speed of or velocity of 10 meter per second. After collision, they are saying, this is before collision, just before collision. After collision, they together, they move downwards. The question says that. Now both are together. So both move downwards at a speed v. Okay, that's a data given. The masses are given. Hammer 1.8 kilogram and the mass of the tent peg 0.2 kilogram. So here nothing is mentioned. You know, we can use law of conservation of momentum. We assume there are no friction acting on it. So you know the law of conservation of momentum could be used when there are no external forces acting on it, or when there are no resultant force acting on one of it, then we can't use. Otherwise we can use the law of conservation of momentum when there are no external force acting on it, right, on the system, right. So if you use the law of conservation of momentum to find the V, so A part, initial total momentum equal to final total momentum. So initial total momentum, mass of the tent peg, that is 0.2 into, it was at rest, mass of the hammer 1.8 into 10. So I'm using this equation downward direction because all the motions are in both are going to move down after collision also. Before collision also the hammer is moving down. So I'll use the law of conservation of momentum downwards. Better write law of conservation of momentum. Okay, now after collision, they are both together moving down, so both have the same velocity. I can use the word velocity because both have the same direction also. So both move together means the mass of the hammer, that is mass of the 10 peg 0.2 into V plus 1.8 into V. So I put both together into V. Okay, solve it. Only the unknown is V. Solve it. You will get the answer for the first part. You will get 9 meter per second. Okay. Second part, find the magnitude of the impulse exerted on the tent peg by the hammer, stating the units and your answer. So you know impulse, you know that Newton's second law, F equal ma. From that only the equation is obtained, the impulse. F equal ma, m into a means v minus u over t. So cross multiply, ft equal mv minus mu. So mv minus mu is the change in velocity. So you know force is a vector, time is a scalar. If you multiply a vector by a scalar, this left hand side is going to be a vector quantity. So ft is a vector. Therefore, change in momentum mv minus mu also a vector. So remember that always the direction of the impulse, so ft is called impulse, so direction of the impulse is along the direction of the resultant force that change the momentum of the object. Say for example here, now when you consider the tent peg has a resultant force downwards. The hammer exerted a force, resultant force on the tent peg downward direction. So the impulse, the direction of the impulse on the tent peg will be downward direction. The hammer was moving downwards until it hits the peg, but finally the hammer stopped because the tent peg is exerting the same magnitude of force according to Newton's third law. When the hammer hits the tent peg accelerates down. It has a velocity which was at rest. Now it has a velocity 9 meter per second. Is it? So that means the resultant force exerted by the hammer on the tent peg made it to accelerate down. So the impulse on the tent peg is downward direction. Always the direction of the impulse is along the direction of the resultant force acting on the object. When you consider the hammer is exerting force on the tent peg. So according to Newton's third law, tent peg will exert same magnitude of force on the hammer. So the hammer will have the impulse, same magnitude of impulse, because both are going to have the same magnitude of force during collision, Newton's third law, and both are going to have the same time of contact. So both will have the same impulse, same change in momentum, right? So the hammer will have impulse upward direction because hammer experiences force upward direction. Anyway, but the question is about find the magnitude of the impulse exerted on the tent peg by the hammer. So I is equal to Ft, which is mv minus mu. Right? So we know that impulse is going to be downward direction. Final velocity is also downward direction. Initially it was at rest. So we'll use that idea, B part, for the tent peg. Okay, downward direction. But they're asking the magnitude, but I just put the direction also, no problem. mv minus mu. So mass of the tent peg is 0.2 After collision, both are moving at the same velocity 9. 0.2, it was at rest before collision. So I am using it for the 10 peg, right? So solve it, you will get 1.8. What's the unit? Mass kilogram, velocity meter per second, kilogram meter per second. That's the unit of the impulse. Okay, so the C part, before that there's a statement. The ground exerts a constant vertical resistive force of magnitude R newtons, bringing the hammer and the 10 peg to rest after they travel a distance of 12 centimeter. Find the value of R. Okay, so immediately after collision, the both move together at 9 meter per second. So there's a friction acting on it. So I'll draw the diagram again, C part. So the hammer and the 10 peg, they are moving together. Okay, so they had initially, at the moment the collision occurs, they started the motion from 9 meter per second. Finally, they are coming to rest. The reason, there's a resistive force. So there's a total friction, total resistive force is acting, contact force. So that total resistive force, let it be R. But they have weight. The total weight is acting down. Both have mass, so there will be weight acting downwards. Mass of the hammer plus mass of the 10 peg into G. So these are the two forces acting on it, but anyway it's coming to rest because R greater than the total weight, otherwise it won't come to rest. So there's a resultant force opposite to the motion will cause deceleration. Whenever object experiences a resultant force opposite to the motion, it will decelerate and stop. So here the R must be greater than the total weight. So they are telling it moved a distance of 12 centimeters. So we'll assume the deceleration is uniform. The friction, the resistive force is constant, they are saying. So the deceleration will be uniform. So they are moving together 12 centimeter and coming to rest. Before collision, they have speed of, immediately after collision, they have speed of 9 meter per second. So we can use downwards the equations of motion for the system both together. They are now moving both together. V squared equal U squared plus 2AS. Finally, they are coming to rest. When they started the motion, their speed is 9, so 9 squared plus 2 times A, we are going to find it, is it? Anyway, we are going to get negative answer because it's a deceleration. And the distance it moved down is 12 centimeter, convert to meter, 12 divided by 100, 0.12. Okay, solve it. You will get negative answer for A because it's a deceleration. They are coming to rest. So you will get A is equal to minus 33.7 meter per second square. Right. Now we need to find the R. We know the two masses. We know it's decelerating. So the resultant force must be upward direction. The resultant force must be upward direction. The acceleration is negative because it's moving down, but velocity was down. Acceleration has a negative, means it's upward direction, opposite to the direction of motion. If the acceleration opposite to the direction of motion, it will decelerate. Whenever an object has acceleration opposite to the direction of velocity, the object will decelerate. So we know the acceleration is upward direction. Okay, I need to find the R. So I can use F equal ma. So I know the direction of A is upward, R is greater than this one. So I can use F equal ma either upward direction or downward direction. Anywhere I can use it. Upward or downward. But when you are using downward direction, if you use this equation downward, that means I am taking down positive if I take it. For A, I should put minus. Because we know acceleration is negative when I consider downward direction. Because velocity downward, acceleration minus, opposite to the direction of velocity. So I can use this equation either downward direction, upward direction, nothing will go wrong. I'll do the both way. So if I take downward direction, this weight is downward, is it? M plus mg, we'll substitute the values, minus r, because r is upward direction, equal to the total mass, m plus m into a, I need to substitute minus 33.8. Okay, we'll substitute the values. Capital M is 1.8, plus 0.2 into 9.8 minus r equal, same thing, 1.8 plus 0.2 minus 33.7. Solve it, you will get the r. So you will get r equal 694.6 Newton, so that is 695 Newton, I can say. Okay, so you can ask me, can't I use the same equation upward direction? Yes, you can, no problem. There also you will get the correct answer. I'll show that way also. Okay, so students normally ask, how do I know the direction of acceleration upward? So we know that it was moving initially 9 meters per second down, and it's coming to rest, means it's decelerating. So whenever an object decelerates, the direction of acceleration will be opposite to the direction of velocity. It's moving down but slowing down, means acceleration should be opposite to the downward motion, that is upward direction. Anyway, I can use the same equation upward direction also. So the same thing I'll do upward direction. One of our method is correct, but one of the way you can use, F equal ma, I'm going to use upward direction. So their upward direction, if I take it, this is upward, so r, this is these two, this force, the total force is downward, so minus m plus m g equal to m into a. When I substitute here a, I will put positive quantity because I know the acceleration is upward, I am taking upward direction positive. Okay, so r minus 1.8 plus 0.2 into 9.8 equal, same way, 1.8 plus 0.2 into a positive value, not negative. Here I put negative because I took downward direction. So again I am telling the same thing, into 33.7. Solve it, you will get the answer correctly as a positive value because r is upward. I took upward positive, you will get a positive answer, 695 Newton. Same answer you will get it. Okay, question number 4 is on vectors. Okay, what should you know related to vectors? We'll just quickly revise only important points. Firstly, you should know vectors could be shown in terms of unit vectors, ij, ijk, but here in unit M1 they consider only one plane, just x and y coordinates, that is ij vectors only. So I is taken along the x direction, this direction is taken I, so this direction will be minus I. This direction is taken j, this direction will be minus j, and this is the origin. Okay, so if a vector is given, a position vector, a vector of a particle at a particular time, we call position vector. If it is given as, for example, 4i plus 3j, what do you mean by this? The meaning of this is, its position in the direction of I is 4 units. 4 units means it could be 4 meters or 4 kilometers or 4 centimeters. We don't need to worry about the unit, but in the direction of I, positive direction, it's 4. So here if I take this is 4. And in the direction of y, that is j direction, it's 3. So in this direction, 3. So if I consider these two lines where they intersect, this is the position. So this is taken as the vector r. So if I take vector r, this is 4i plus 3j. So the meaning of vector 4i plus 3j is in the direction of I 4 units, in the direction of j 3 units. So this is the vector r that you must know. So if I can name this A. Now there could be another vector, that is q, that is 6i minus 5j. Maybe its direction is like this. So 6i minus 5j means that vector q is, it represents another vector, that is maybe this is representing a point A, this is representing point B. I will name it R1. So this is R1, this is R2, easy rather than Q. R2, 6i. So 6i means somewhere here, I direction 6 units. I direction 6 unit. y direction minus 5. I can write this plus minus 5j. That way also we can write. So in the j direction, minus. This minus could be taken here, minus j. So that means 6i, here 6, minus direction 5. So that could be, this is the point B. This is minus 6, this is, sorry, minus 5. That is 6, this is point B. Right. Now they can ask you to find that, the meaning you should know then. Then they can ask you to find the vector AB. Vector AB. Or displacement from A to B. The displacement vector from A to B. Some particle is moving from A to B. So the displacement vector. So how to find the displacement AB means, we know the vector addition rule. AB means AO. Start from here. We need to find the AB. So we need this vector A to B. AB is the vector we want. So AB means AO plus OB. AO plus OB. So when you consider this triangle, AB, the vector AB is equal to AO. Start from AO plus OB. OB is the vector R2. So AO plus OB. That's the vector addition rule for vector AB. Okay, what is AO? We know OA. OA we know, that is OA is R1. AO means negative R1. Because when you invert the vector, it will be given with negative sign. Say for example, vector towards north, if I say R, vector towards south is minus R. So when the direction is inverted, it will be written with minus R. You should know that, you would have learned that. So AB is equal to AO plus OB, but vector R1 is OA, from O to A. This is OA, vector OA. This is vector OB. O is the origin, OB. So AO means negative OA, that is minus R1 plus R2. Minus R1 means minus 4i plus 3j plus R2 is 6i plus or minus 5j. Okay, if you solve it, you will get the vector AB. So that's vector AB will be minus 4i minus 3j plus 6i minus 5j. So that's going to be 6i minus 4i, that is 2i, minus 3j minus 8j. That is the vector AB. So maybe they can say a particle was initially at position vector A, which is given by 4i plus 3j. Later, after 5 seconds, something like that, after 5 seconds, it has reached a position vector or point B, which has a position vector 6i plus minus 5j or 6i minus 5j. And they'll use the word it's moving at constant velocity. Constant velocity means its direction is not changing. So it's moving from A to B on a straight line. Mostly question says constant velocity or constant acceleration. No change in direction. It's moving on a straight line. So the motion from A to B, the vector AB, the displacement vector AB is given by AO plus OB. AO means minus OA. So minus R1 plus. So solve it. You will get the displacement vector 2i minus 8j. Okay, so they might say it moved from point A to point B during time of 4 seconds. We'll say it takes time to move from A to B. The time taken is 4 seconds. So they can next ask, find the velocity vector. So they are saying it's moving at constant velocity. So displacement vector is 2i minus 8j. Time taken to move from A to B 4 seconds. So what's the velocity vector they can ask? So velocity vector we can find it by dividing displacement over time, is it? So velocity vector could be given as velocity vector displacement vector divided by time. So displacement vector is 2i minus 8j divided by the time 4 seconds So you will get velocity vector 0.5i minus 2j. This is the velocity vector. Okay, so these are the normal questions comes. Right. Now if you know a vector, it could be a velocity vector or displacement vector, you must be able to find the magnitude of it. So this is the position vector, initial position vector, sorry, not a displacement, it's a position vector. Initially the position is 4i plus 3j, later the position is 6i plus minus 5j or 6i minus 5j. So AB is the displacement vector. So here they can ask to find the the magnitude of the displacement. Maybe they might give the values 6, 4 all in meters or kilometer, whatever it is. They can ask you to find the magnitude of the displacement during the 4 seconds. So how to find the magnitude of a vector means, we'll find the magnitude of a vector now. Okay, how to find the magnitude of a vector? Say for example, a vector is given R is equal to AI plus BJ, general format. How to find the magnitude? The modulus is given by square root of A squared plus B squared. Why is it like that? As I told earlier, in the Cartesian coordinate, this is I, this is J. So RAI means in the I direction A, J direction B. So this is the point. This is the point. So magnitude means from O. O is the origin. From O the length. So this length means this length is A, this length is B, Pythagoras theorem. This length is A means A squared, this length B squared, square root of it, that gives the length of the vector R. So that's the magnitude. And also you must be able to find the direction. If the vector is R, you can find the direction with I direction. With the direction of I, you can find the angle. So this, if I take angle theta, tan theta equal opposite B over A. That is the value of the J component over I component. Okay, that is the angle theta. Okay, right. So we found the velocity vector, that is 0.5i minus 2j. That's a velocity vector. That means, what do you mean by that? Means the component of the velocity in I direction. Earlier I did this. The component of the velocity in I direction, that means along the x direction, is 0.5 meter per second or kilometer per hour, depending on the units. But here we took meters, at the time I told 4 seconds. So the component of the velocity in the x direction, along the I direction is 0.5 meter per second, and along the j direction towards down, not upwards, towards down, 2 meter per second, because minus 2j, so that means towards downwards 2 meter per second is the component. Along the x direction towards right, that is 0.5 meter per second. So that is the meaning of this velocity vector. Okay, next thing you should know, we know the coordinate A, that is OA. We know the position vector of point A, that is R1. That is 4i plus 3j. So I told that an object was initially at that point A. During 4 seconds, it's moved at constant velocity. That's the way they say. Constant velocity means the reason the word constant velocity, constant is used, the direction is not changing. The angle is moving on a straight line. That's the meaning of it. So constant velocity is moving to point B during 4 seconds. And the position vector of B, that is OB, also I gave earlier, that is 6i minus 5j. And we found the velocity vector, this one. Okay, so they can ask, they can say, the questions can say that the object is moving at constant velocity on a mean straight line. At time t, what could be its position vector? So it started when t equals 0, it was at position vector A. Then what could be the position vector at time t? We know that it's moving from A along this line. So maybe at time t, whether it bypass the B or whatever it is, it's going to be on this line. So at time t, it could be somewhere here. Let it be C. We need to find the position vector of R. Is it? That's the position vector at time t. At time t equal t, this is at time t equal 4 I said. This is t equal 0. So at time t equal t, what is the position vector? That is I need to find the r. That is I need to find the OC. Right? How to find it? It's moving at constant velocity. So the displacement vector AC is going to be velocity vector into time. So OC I need to find, that is the position vector at time t. OC is going to be, that is R. OC is going to be OA plus AB. OA plus AB. Right. So OA, we know that OA, that is the position vector of A, that is 4i plus 3j. That is OA, the position vector of A. Initially it was at there. That is OA, that is 4i plus 3j plus AB. The vector AB is the displacement vector. So we found it, vector AB. That vector AB we found it already. Sorry, there's a mistake I made. OC plus AC. Sorry, AC I need to find it. AC, right. Okay, not AB, AC. OC equal OC OA plus AC. Sorry. Right. AC means velocity into the time. So it's moving at constant velocity. So that is 0 point constant velocity into time. So 4i plus 3j plus the velocity vector, we know that 0.5i plus, minus 2j into t. That's going to be 4i plus 0.5 ti plus 3j minus 2 tj. So we'll take the I and j common. So 4 plus 0.5 t into I plus 3 minus 2 t j. This is going to be the position vector at time t. Okay, we'll substitute and check. When time t equal 4, are we getting the position vector of B? Substitute time t equal 4. So if you put time t equal 4, you will get 4 into 0.5 is 2. You will get that 4 plus 0.5 into 4 I, because I am checking whether our equation is correct. Because at time t equal 4, I should get the position vector B, because we used that to find the velocity, plus 3 minus 2 into 4 j. You see that? That is going to be 2 plus 4, 6i. This is 3 minus 8, that is minus 5j. Yes, correct. No, we are getting the position vector of B. So this is the general equation. This is the general equation at time 4 seconds, right? So this is the general equation. Very common question. It comes in the past papers. They asked to find the position vector at time t. Okay, so we'll go to now question number 4. They are saying in this question, I and j are horizontal unit vector directed due east and due north respectively. Normally that's the way the I and j are defined. A particle P moves with constant acceleration. Okay, the word constant here, acceleration also used. Doesn't matter. The meaning of constant here, the direction is not changing. The velocity, the speed is going to increase, but the direction of motion will remain the same because acceleration is constant. Constant acceleration of minus lambda I plus 2 lambda j meter per second square. So they are saying the acceleration vector is minus lambda I plus 2 lambda j meter per second square. So that's what's the meaning of it? Means the component of the acceleration in I direction is towards left. So that means if you consider the components towards left, there is a component of acceleration, that is lambda. So since I put left, I don't put minus sign because I know the direction is towards left, because they are defining I is towards right along x direction. So minus lambda means towards left, the component of the acceleration. You know vector, you can resolve it, but here they don't ask you to resolve, they are giving the components directly. So towards left, the acceleration value is lambda. In j, positive direction, upward direction, that is along the y direction, j, the component is 2 lambda. That's the meaning of it. If you find the Pythagoras theorem, you will find the actual magnitude of it, right? Anyway, we don't need that. The question is, so we know that if these lambda, 2 lambda, they are constant, so the resultant is going to be a constant, is it? So no change in direction. That's the reason they say constant acceleration, right? At time t equals 0, velocity of p is 5I minus 8j. Okay, so velocity vector also given 5I minus 8j meter per second at t equals 0. So what is the meaning of it? The component of the velocity in I direction is 5, the horizontal component towards right, towards east they are using the word, so towards east is 5 meter per second, towards north is minus 8, so that means towards south, the velocity is towards south, that is the component 8 meter per second. That's the meaning of it, right? So the acceleration, there is acceleration. So you know, by using the equations of motion, we can consider the acceleration or the velocity at time t. In horizontal direction, it's going to accelerate towards left. So towards right, it had a velocity. The acceleration is towards left. Here the velocity is towards upward direction. Sorry, velocity is towards downward direction, towards south. Acceleration is towards, doesn't matter. We can use the equations of motion. So we know that its object is going to decelerate because the velocity is towards right at time t equals 0. Acceleration is towards left. In case if it is a lambda is a positive quantity, they are saying it in the question. Yeah, when you solve, you will get lambda value also positive. Lambda is a positive constant. They are telling it in the question. So that means a positive quantity. The direction of the acceleration is towards left. That is towards west. But the velocity initially towards east, opposite to the velocity acceleration, means yes, in horizontal direction the velocity is going to decelerate. The velocity 8 meter per second towards south, but acceleration is towards north, opposite. So it's going to decelerate. So finally the whole velocity is going to decelerate. Anyway, we don't need that, but it clearly shows that the values. Okay, so the first part question. Find the velocity of p when t equals 5 seconds, giving you answer in terms of I, j and lambda. Okay, so we need to find the velocity at 5 seconds, means we can use the equations of motion, that is a part we can use the equations of motion, v equal u plus at. These all are vectors. So the initial velocity, so this we can say u, the initial velocity when t equals 0 is given. So v equal u plus at, we can use it. So the initial velocity, that is 5I minus 8j plus the acceleration is minus lambda I plus 2 lambda j times time t is 5 seconds. Fine. So solve it. So you will get 5 into minus lambda minus 5 lambda I. So here I 5 minus, multiply inside, 5 lambda I plus minus 8j plus 10 lambda j. That is the velocity vector. Okay, that's the velocity vector at time 5 seconds. Okay, second part, the speed of p when t equal 5 seconds is 13 meter per second. So we know the velocity vector at time t equal 5 seconds. So this is at 5 seconds. At 5 seconds, this is the velocity. This is the velocity vector because I and j are there. Okay, so they are saying at the speed of p when t equal 5 seconds is 13. Now they are giving the magnitude. I told that if you know the vector, it could be a displacement vector or velocity vector or position vector, whatever it is, to find its actual value, the numerical value, you need to use Pythagoras theorem. That means in I direction this much, j direction this much. So I direction this much, that is 5 minus 5 lambda. J direction, that is minus 8 plus 8 lambda. So you need to find the actual value. This is the thing we are going to find it. So that means you need to find the Pythagoras theorem, like this squared plus this squared square root, right? So that is the B part. So they are saying the magnitude is 13 meter per second. So that is 5 minus 5 lambda all things squared plus minus 8 plus 10 lambda all things squared equal to 13 squared, we can say. Or here we can take the square root, but I'll put 13 squared, easy to solve, because anyway I'm going to square it. Is it square root, keeping it inside square root solving is difficult. Okay, so solve this one. If you solve, it will be 25 minus 50 lambda plus 25 lambda square plus 64 minus 160 lambda plus 100 lambda square equal to 13 square, that is 169. Okay, rearrange it. You will get finally 25 lambda squared minus 42 lambda minus 16 equals 0. So they asked to show this. We are getting that finally. Okay. Okay, C part, find the direction of motion of P when t equals 4 seconds, giving you answer as bearing to nearest degree. So the bearing is not a problem. The direction of motion. Student says, what's the meaning of direction of motion? Means direction of velocity. Always the motion will be along the direction of velocity. Now you can't have any type of motion in which the velocity is in one direction and the displacement in some other direction. No, when it moves on a straight line, always the direction of motion means the direction of velocity, right? So we need to find the direction of velocity at 4 seconds. We have the velocity vector, we found it at 5 seconds. So this is the general equation, we found it at 5 seconds in terms of lambda. But we know the speed 13 meter per second. So finally we got this equation. So lambda is a constant, they are saying. So by using this quadratic equation, we can find the value of lambda. By using the calculator, you can find the lambda. So find the lambda by using calculator. So when you use calculator, you will get the answer for lambda, that is C part. It's a positive value. They are saying lambda you will get 2 or minus 8 by 25. So this we don't take. So lambda is 2, right? So we need to find the velocity, the direction of motion at 4 seconds. So we have the equation for 5 seconds. So same equation. So same thing, v equal u plus 80 we are going to write, but time we are going to 4 seconds. We know the lambda value. So we are going to substitute the value of lambda also. So we will get the velocity vector at 4 seconds. Then we are going to find tan theta, but we are going to use the bearing. I'll tell you the bearings. First we will find it. So lambda equal 2. We'll use v equal u plus 80 at 4 seconds. So it's going to be u, we know that 5y minus 8j plus the acceleration is minus lambda I plus 2 lambda j. So minus lambda means minus 2i. Lambda we found it. So minus 2i plus 4j into 4, because they asked to find at 4 seconds. Earlier we found it at 5 seconds. Now they are asking to find the direction of motion at 4 seconds. So I substitute time 4. Okay, solve this. You will get minus 3i, 5i, minus 2 into 4, minus 8. So minus 8, 5. So you will get minus 3i, minus 8j, plus 60, plus 8j. I think I'm right. Yes. This is the velocity vector at t equal 4 seconds. Okay, so I need to find the direction. So if I What's the meaning of it? The direction of the component of the horizontal velocity is -3. So that is towards left 3. This is 3 meter per second. Towards north, that is 8. So the direction of the resultant is going to be along this direction. It's going to be this direction, the resultant. We'll find this angle. We'll find this angle first, theta. But they ask you to find bearing. So the bearing means angle should be measured in degree in clockwise direction from north. So we need to find this component. We need to find this angle, that is from north. We'll take this angle alpha. We'll find that alpha. So we need to find, this is the bearing. From north in clockwise direction, we need to find it. This angle we need to find it, is it? That is the bearing. If this is alpha, this also alpha. This also alpha, is it? Alternative angle, this also alpha. So this is 3 meter per second, this is 8. We'll find the tan alpha. Tan alpha 3 over 8, find the alpha. So you'll get alpha equal 21 degree. You can take it 21 degree, 20.6, so you can take it 21. But the bearing is from the north this much. So this is 360, the total is 360 minus alpha. So bearing, the angle bearing. So if you give it in bearing, 360 minus 21, that's easy to do that way. That will be 339. So that's the bearing at 4 seconds. Okay, question number 5. A small ring of mass 0.2 kilogram is attached to one end of a light inextensible string. Light means we don't consider the weight of or mass of the string. Inextensible means it is cannot be extended. The ring is threaded onto the fixed rough vertical rod, means it just put it there. It's threaded, so it can move freely up or down, but there will be friction. The string is taut and makes an angle theta with the rod as shown in figure 3, tan theta 12 by 5. So tan theta 12 by 5 means, if you consider so this is theta, tan theta 12 by 5 means 12, this is 5 means this will be 30, is it? Okay. Given that, we can draw the diagram, not necessary to draw the same shape, but I did it for you to understand, easy for that. It's not necessary, we can draw anyway, it's a trigonometry, not exactly, should not tell, you can even draw the theta like this. But anyway, just to avoid confusion, I drew it exactly the same way. Right. Given that the ring is in equilibrium and that the tension in the string is 10 Newton, find the magnitude of the frictional force acting on the ring. Okay, so the frictional force acting on the ring, we don't know the direction of the friction. Yeah, so that's the reason the next part, maximum minimum tensions are there. Anyway, you know, at limiting equilibrium, the friction is given by F equal mu r. Why r? The normal reaction comes because the amount of friction that depends on how much of contact the two surfaces have. For example, if on a floor, if you keep a block, some block, right, something like a wooden block or something, and if you try to pull it horizontally, the mass of the block, if it is m, the normal reaction r will be equal to weight of it, because vertically there is no motion, so r should balance the weight. So r will be equal to weight of it. So the friction is given by friction force. Sorry, if you are pulling it to the right, the friction, the limiting friction is given by Fr equal mu r, where r is equal to mg, because vertically there is no motion. The normal reaction must be equal to mg. Right. Now, Why the friction depends on sometimes students ask, nothing related to mathematics, but in physics they ask. The reason, the friction depends on how much of contact these two surfaces have. If you increase or if you make the contact very strongly, then the friction will increase, because at microscopic level, the two atomic surfaces can have more contact, that will increase the friction. So when you apply a force on the top of it downwards direction, then the R also will increase. When the R increases, friction will increase. So here, the ring is going to be, anyway, the string is exerting a tension this direction. So this left hand, if I draw enlarged diagram, we'll see, try to draw enlarged diagram, something like that. The ring is going to be something like this. The left end of the ring is going to touch it. So the tension on the string, the ring is this way if I consider. This is the portion going to give the normal reaction. That normal reaction will decide the limiting friction, F equal mu r. But the friction could be either up or down. The reason, depending on the tension, say if the tension is not sufficient to hold it, or if you imagine you are holding this ring and the ring is at rest. Gradually reduce the tension. What will happen? When you gradually reduce the tension, the ring might slip down on the rod. So if the ring try to slip down, the friction will be, if the ring is at an limiting equilibrium such that it's going to slip down, means friction will be in upward direction. In that situation, the friction will be in upward direction. You try to increase the tension gradually. So when you try to increase the tension, what's happening? The component, vertical component of the tension can pull the ring upward direction, and there's a chance it's going to slip upward direction, or it's going to move upward direction. Not yet move, but it's going to move upward direction. So the friction in that situation, the friction will act downward direction. Okay, so there is a chance the ring can slide either upward direction or downward direction depending on the value of tension. I hope you understood. If you reduce the tension, anyway you are holding it, it's at rest. Okay, you just put it and you are holding it, it's at rest. Okay. But gradually reduce the tension, there's a chance it will try to slide down. In that situation, the friction will be upward direction. The limiting friction will be upward direction. Same way, gradually increase the tension. When you gradually increase the tension, there will be a limiting condition, limiting equilibrium. In that limiting equilibrium, the ring will try to move upward direction or slide upward direction. So friction will be downward direction. So in this question, I don't know what is the direction of friction. Nothing is mentioned. I will just take the direction of friction. I took it like this. I took the direction of friction is upward direction. When I solve, if I get negative answer, friction is down. Before starting answering, we don't know which direction. You just take it. Okay, you just take the friction. Which direction you are getting it. If you get positive answer, the direction you got is correct. If you get negative answer, you have to change the direction of the friction. Okay, for this question. But next question is interesting. Maximum, minimum value of the friction. There, when we are considering maximum, minimum, we have to consider what I explained now. That situation we have to consider. Okay, one more thing. So the ring will have contact here. The left end of the ring will push on the rod that side. The left end of the this end of the ring will push the rod this way. So rod will push it this way. So the normal reaction acting on the ring due to contact with the rod is going to be this way. So this is the direction of normal reaction. That also you must know that. That's a contact force. Okay, so we'll draw the forces acting on the ring easy to handle it. So if I consider the ring, so it has weight acting downward direction. The tension is acting this direction. That is given the tension. Yeah, that's given. And the friction, I'll take the friction is acting upward direction. I don't know whether its friction is acting up or down, I don't know. But I'll take upward direction. If I get negative answer, I'll change my direction. And there will be a normal reaction. So I told the left end of the ring is going to touch the rod, so the normal reaction acting on it will be left side. So these are the 4 forces acting on the ring. You must be able to identify the forces, otherwise your answer will go wrong. Okay, so the question is find the magnitude of the frictional force acting on the ring. Okay, so we will see the ring is at rest, equilibrium. So the resultant force in any direction must be equal to 0. So this is the A part. So we will take upward direction, resultant force must be 0. So this angle is theta. So here I found it. So tan theta given 12, tan theta is given as 12 over 5. So cos theta 5 over 13, is it? Cos theta 5 over 13 and sin theta 12 over 13, right? Okay, so we'll consider upward direction, the resultant for 0, so that is Fr, the friction, minus mg plus T cos theta equal to 0, right? So the tension is given 10 Newton, so Fr, the mass of the ring also given 0.2 kilogram into 9.8 plus 10 into cos theta, I found it here 5 by 13 equal to 0. Solve it. All numbers, only Fr is the unknown. Solve it for Fr. When I solve, I get Fr minus 1.9 Newton. So I am sure I took it upward direction Fr, but I am getting negative answer, means this is upward direction, is it? I took it upward direction, but I am getting negative answer. So friction is equal to 1.9 Newton downwards. Okay. B part state the direction. So I mentioned that here. So B part downwards. If you take already, if you took this Fr downwards, you will end up with positive answer. So the answer is downwards. Anyway, you are getting positive answer. But I took upward direction, I am getting negative answer. Okay, so B part, state the direction. Okay, that I did it. Now next part, before C part, the coefficient of friction between the ring and the rod is 1/4. So again, that is on the left end. That will be due to the contact on the left end of the ring. 1/4, that is mu, coefficient of friction. Given that the ring is in equilibrium and that the tension in the string T newtons can now vary. Earlier it was 10, now it can vary. As I told, you can increase the tension. When you increase the tension, the ring will be try to slip up. It will be in limiting equilibrium and it's going to slip upward direction. The friction will act downwards. Same way when you reduce the tension, right, gradually, still it's in equilibrium, but it's not sliding down, but it's going to slide. So when you reduce the tension, it will try to slide downwards, not sliding, but it's going to slide. It's equilibrium, limiting equilibrium. It's going to slip down, friction will act upward direction. Find the minimum value of T and find the maximum value of T. Okay, so I already explained it. So I'm going to use that idea. So first they asked me to find the minimum value of T. So minimum value of T means you are going to reduce the tension. Earlier it was 10 Newton. So from the 10 Newton, you are going to gradually, step by step, slowly, when you reduce the tension, still it's in equilibrium. But at a particular instant, it's going to, but it's not sliding, it's about to slip down. You are reducing the tension. So that means the minimum tension that can keep equilibrium. That's what we are going to find it. Minimum tension that could keep the ring at equilibrium, we are going to find. So that happens when you are reducing the tension, it's going to slip down, not slipping, it's about to slip down. Friction will act up. The friction will act upward direction. So in that, we are going to find the minimum tension that could keep the ring at equilibrium. So I am going to find the minimum tension, right? Okay, so in this situation, the theta is the same, no change in angle. We are still keeping the direction of tension the same, only the values are kept constant. So first, that is C part, first part. So we are considering the minimum tension, means you are reducing, it's going to about to slip down, friction will be upward. So now I know the direction of friction, it's upward direction. And we know that Fr equal mu r mu is given, we'll use that. Okay. So here the same way, when I consider equilibrium in upward direction, I can say T cos theta plus Fr minus mg equal to 0, but Fr equal to mu r. So T cos theta plus mu r minus mg equal to 0. Okay, so T cos theta is equal to mg minus mu r. Right. When I consider in horizontal direction, it's at equilibrium. So when I consider, I can take this as first equation. So when I consider horizontal direction, it's in equilibrium. So the resultant force in any direction must be equal to 0. So that is T sine theta minus R. That's the contact force. I already explained, when the ring touches the pole or the rod at this end, it will try to pull the rod this way. So rod will exert a normal reaction this way. So minus R equal to 0. So T sine theta equal to R. Okay, so instead of R, from the first equation, I can say T cos theta equal to mg minus mu. Instead of R, I can put T sine theta. So minus mu T sine theta. We know all the values. We know everything. Only we don't know the tension. Cos theta we know, weight of the ring we know, mu we know, sine theta we know. Substitute that. Okay, so cos theta, that is 5 over 13. So here I am finding the minimum tension. Is it? This is for the minimum tension, because I told that already. Reducing the friction is at up because it's trying to slide down. When you reduce the tension, means you are getting the minimum tension to keep the ring at equilibrium. Right? Okay. I don't need to tell again and again. T cos theta is 5 by 3, 5 by 13 equal to mass of the ring is given 0.2 into 9.8 minus mu, that is 1/4. Yeah, 1/4 T into sine theta 12 by 13. Okay, everything we know except T. Solve it. That's not an issue. You will get 5T over 13. This is 4/3 plus 3T over 13 equal to 0.2 into 9.8. Okay, 80 over 13. Anyway, you solve it. You will get T is equal to, solve it. T is equal to 3.19. If I give it in 1 decimal point, 3.2 Newton. That is T minimum. That's a minimum tension, because we are reducing the tension. It's about to slip down. Right. This answer for the C part, first part. Okay, T part, C part, second part, maximum tension. So maximum tension means we are going to increase the tension. When we increase the tension on the string, there will be a point at which the string will try to slip up. So the friction will be downward direction. The limiting friction will be downward direction. So there the friction is going to act downward direction. So the diagram is changed now. So this is maximum tension. I am keeping maximum tension such that the ring is at equilibrium. So same way do it, you will get the answer. Okay, so here also it's at equilibrium, upward direction. T cos theta minus mg minus Fr equal to 0. Fr equal mu r. So T cos theta equal, take mg to the right, mg, Fr go to the right, Fr equal mu r plus mu r. Okay, so when I consider horizontal direction, so this I'll take it equation 1. Horizontal direction, T sine theta equal to r. Substitute T sine theta in this r. So T cos theta equal to mg plus mu T sine theta. Okay, substitute the values. Now you know all. Same thing as earlier. Cos theta is 5 by 3, 5 by 13. equal to 0.2 into 9.8 plus mu 14 t sine theta 12 by 13. Okay, now you know how to solve it. That also going to be 5 by 13 minus 5t over 13 minus, so 3t over 13 equal to 0.2 into 9.8. So here find the T, that is going to be maximum T. So T maximum, solve it. This is the maximum tension to keep the ring at equilibrium. So you'll get 2T over 13 and solve it. 2T over 13 equal this much. Solve it. T maximum you'll get 12.747 Newton, I can say. That's the maximum tension. Okay, question number 6. Again, it's vector. Same idea what I explained in question 4. The same thing I'm going to do here. In this question, I and J are horizontal unit vectors directed due east and due north respectively, and position vectors are given relative to a fixed origin O. O is the origin, yeah. At 12 o'clock, right? That's the question starting at 12, means 12 o'clock. A ship P sets sail from a harbor with position vector 59 plus 36j kilometers. So that's a position vector of the ship P at 12 o'clock. At 12:30, that means after 30 minutes. That is 12 to 12:30 means half an hour, is it? 0.5 hours later, P is at a point with position vector 20I plus 34j kilometers. So it's here the measurements are given in kilometers. So if I just put a simple diagram, not necessary to draw, but for your understanding. So that means I and J, if I consider, this is I, this is J direction. At 12 o'clock it was at, we'll take the position where it was at A, we'll take that as A. It's not mentioned, but I'll take it as A. This is the origin O, right? At A it is 59 plus 36j. 59 plus 36j. So you know the meaning of 59. X component 15, Y component 36. So this is the OA, we'll call this vector. This is the position vector OA. If you want, you can name it R1. It's okay at 12 o'clock. That is at 12 o'clock, right? Right. So late at 12:30, the position vector is 20I plus 34j. 20I. So I is 15. If I take 20I still somewhere here. 20I plus 34j. So it's slightly lower than Y value. Somewhere here we'll take it. That we'll take it as B. Somewhere here, right? Somewhere here. This is B. So its position vector 20I. I'll put it here. Bracket I'll put it. 20I plus 34j. So this is the position vector. OB is the position vector at 12:30. Right. So the displacement. So it's moving at constant velocity. I told that they'll use the word constant velocity. So it's moving at constant velocity means direction won't change. It's moving from A to B. During that half an hour, it moved from A to B. It can go beyond that, we don't know, but it moved from A to B. Right. The question is, show that the velocity of P is this much. So how to find the velocity? We need to find the displacement vector. Displacement vector is AB, right? So we know that I told that that is A part. I need to find the first displacement vector AB. That is AB equal AO plus OB. You know that's a basic vector addition rule. Vector addition rule. So in a two vectors, if they are added, if this vector is A, if this vector is B, the arrows should follow each other. If this is the vector R is equal to vector A plus vector B. That's a basic vector addition rule. So I need to find the vector AB. Vector AB means vector AO plus vector OB. Vector AO means when you invert, because we know OB, we know we know OA. OA is 59 plus 30J. OA is the position vector respect to O. OA, that's the position vector that I took R1. This I can take R2. So R1 means OA, but in the addition it comes AO. So that means minus OA plus OB. Right. Can put arrow here, no problem. So minus OA, what is it? Minus OA, that is 59 plus 36J plus OB, that is 20I plus 34J. It's a basic thing, nothing logic, no logic, just normal method. It's a method, right? Solve it in terms of I and J. You will get 20I, 59, so in minus comes here, minus 59 plus 20, so 5I, 34J minus 36 minus 2J. That is vector AB. So that's a displacement vector. It moved from A to B. That's a displacement vector of the sail P. That's a ship, ship P. But they asked to find the velocity vector. So they asked to show that the velocity. So velocity is equal to displacement vector over time. So that is 5I minus 2J over time is 30 minutes. 12 o'clock it was here. 12:30 means half an hour, is it? 30 minutes past half an hour. So the question is in kilometer per hour. So 0.5. So that's going to be 10I minus 4J. That's the answer. That's the velocity vector. It's easy, nothing. It's interesting and also easy. Yeah. Okay, so this is at after half an hour, right? It was at B. So generally at time T, where will it be? We don't know. It will be somewhere. Maybe it would have passed B, or before passing B, somewhere between A and B. We don't know. We'll take just somewhere here, but it's moving at constant velocity. Constant velocity means direction is the same. So I'll just take beyond B. I don't know where the time is. Generally they are asking. So it's somewhere here I can take, or just somewhere here I'll take. It doesn't matter. C I'll take it at time T, right? So the question is, they are asking to find the question. They asked to find the position vector at time T. Position vector at time T. So position vector at time T means we need to find OC. That's a question. Position vector at time T means OC. I need to find it. That's a B part. So OC I need to find it. That's a position vector. So that they are giving a name, position vector P. So I'll name it as P. Position vector OC is equal to OA plus AC. What is AC? What is AC? That's a displacement vector. How to find the displacement vector? Velocity into time. The displacement vector means if I know the velocity vector into time is the displacement vector, right? So remember that displacement vector, if I know the velocity and time, velocity time is the displacement vector. So OA we know that 59 plus 36J plus AC means velocity vector what I found here into T. Time is a scalar, right? Solve it. 59 plus 36J plus velocity vector I know that 10I minus 4J into T. Solve it. You will get the answer for the B part. So you will end up with that will be 59 plus 10IT. So 15 plus 10T. I correct no? I'm doing 15I, 10IT. So 10TI plus 36J minus 40J. That's the position of E at time T. If you want to check whether I am correct, for T put half an hour and check whether we are getting the B. Check it just if I am correct. Instead of T, they are not asking, but just to check. Instead of T, put half an hour because it reached the point B at half an hour, 12:30 is it? So put half an hour means 15 plus 10 into 0.5 I plus 36 minus 4 into 0.5 J. Are we getting it? This is half an hour means this is going to be 5, 15 plus 5, 20 I plus 36 minus 2, 34 J. Is it the coordinate of B? Yes, 20I, 34J, 34J. So it's correct, no? So it's a general format. That's the question it asks. We found the general format of position vector. Right. So it's correct, right? Okay, so next part. A second ship Q is also traveling at constant velocity, so direction is not changing. At time t hours after 12 o'clock, the position vector of Q is given by Q kilometer. They are giving 42 minus 80I. Okay, they are giving it, right? So P and Q are modeled as particles. If both ships maintain their course, C part for verify that they could collide at 13.30 time. 13 point. So the whole question is started at 12 o'clock. Now 13.30 means after 1.5 hours, actually 1:30 p.m. right? So at after 1.5 hours, 3/2 hours, will they collide? That's a question, right? If they want to collide, what should happen? Both should have the same position coordinate. If they are colliding, both P and Q should be at the same point. Then only they can collide, is it? So they should have the same position coordinate, right? So to find it, we'll check it whether will they have the same position coordinate. So it's like a checking, nothing big. So C part, first part, this is the position vector of P. We know that position vector of Q, the ship Q is given 42 minus 80I plus 9 plus 14, 14T J, right? So we can do like this. That means at 12 o'clock the journey started. Now it's happening at, this is at time T. They are saying the question that time T hours after 12. So Q also the time is measured from 12 o'clock. So both have the same time, right? So this is happening at 1:30 p.m. That is 13:30 means after 1.5 hours, 3/2. We will find the position vector of P and position vector of Q. If they are same, exactly the same, that means exactly the same means I components should be the same, J components should be the same. If that happens, they have the same position vector at 13:30, that is at 1:30 p.m. They will collide. We'll check it that way. That's easy method. Otherwise, you can solve this. If they are colliding, they should have the same coordinates. So this way also you can find 15 plus 10t equal 42 plus 80. Find the time. Then 36 minus 14 should be equal to 9 plus 14t. Find the time. Both should have the same time. Both time. This time when you solve the value you get, this time what you get should be the same because they can't have different time, is it? So same time. So if that same time you get, that means they are going to be at the same point. But I feel it's better to find the coordinate of P and Q at 13:30. 13:30 means T is started from 12 o'clock. Now 1:30 p.m. means 1.5 hours later. So for P, we'll find it. That is 15 plus 10 into 3/2 I plus 36 minus 4 into 3/2 J. So that will be 5, 15, 30I plus 36. This is 2, 6, 30 J. That's for at that is position vector of P at 13:30. Right. For Q we will find it. 42 minus 18 to 3/2 I plus 9 plus 14 3/2 J. So it's going to 42 minus 2, 4, 12, 30 I plus 9 plus 14, 7, 21, yes. 30J, yes, both have the same, exactly the same coordinate, 30I plus 30J, 30I, 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 30J, 30J, right? So they are going to be at the same coordinate, they will collide. That's the answer, you should finally write. Since both have the same, I am not writing, you write it. Since both have the same coordinate, same coordinate, exactly the same coordinate, they will be at the same point at 1330, they will collide. Second part, C part, find the position vector of the point at which the collision would occur. Yeah, anyway, we found the position vectors. We did that, so nothing to do again. So just put 13I plus 13J. See, already we found it, is it? That's the answer, second part. Okay, part D. At 12:30, Q changes speed and direction to avoid the collision. So we know that they are going to collide, is it? So at 12:30, before collision, so the collision is occurring at 1:30 p.m. So at 12:30, it changes. Q is changing its direction of motion. This changes speed and the direction of to avoid the collision. So until 12:30, so the time generally the the position vector for Q is given where T is measured from 12 o'clock. This is at 12:30. So until that 12:30, it's following this position vector. Now no change in its velocity because position vector with time means it includes the velocity. So this position vector given in the exam paper, T is from 12 o'clock. So until 12:30 for half an hour, it's following this position vector. Then only it's changing, right? So we will find, okay, anyway, I'll read the question. 12:30, Q changes speed and direction to avoid collision. So until that, it would have followed the same position vector because T is a variable. So it's changing with time. For half an hour, it would have 30 minutes. Half an hour, it would have followed the same position vector. Right. Then ship Q now travels due north with a constant velocity, constant speed of 15 km per hour. So after that, it's changing its velocity towards north 15 km per hour. So 15J towards north means 15J is the velocity after 12:30, right? Ship P maintains the same constant velocity throughout. So P has no change in its velocity. So P's position vector remaining the same, no change in its velocity. So its position vector depending on the time is changing with time. Okay, so that equation is the same for P. It's not changing. Right. Find the exact distance between P and Q at 2:30 p.m. Right. At 2:30 p.m. we need to find the distance. So the idea, I'll tell you the idea. Anyway, we'll find it, but the idea is at 2:30 p.m. I need to find the exact position of P. So that means I need to find exact position of P means I need to find OP. That's the position vector of P. At 2:30 p.m. I need to find the position vector of Q, that is OQ. O is the origin. I need to find it. Then the question is find the exact distance between P and Q at 2:30. So after finding the position vector of P and position vector of Q, that is OP and OQ, I should find the position vector PQ. Then find the magnitude of it. Okay, that's all. Right, okay. So we'll do like this. We'll see that at 2:30 p.m. that is at 14:30. At time 14:30 means 12 o'clock. The P time is started from 12 o'clock. Yeah, T is starting from 12 o'clock. So this time taken by P, 2:30 means 2.5 hours, is it? So we'll find it. That is D part at 14:30 means time duration is 2.5, 5/2 hours. So the position vector of P equal, we use this equation 15 plus 10t, so 10 in 10, yeah, 10t, I'll write this and substitute 10t I plus 36 minus 4t j, so t is 5 by 2, 15 plus 10 into 5 by 2 I. Okay, I plus 36 minus 4 into 5 by 2 j, so it will be 10, 25, 40 I plus 26 j. So this is a position vector P of shape P at 12:30 p.m. Sorry, 2:30 p.m. Right. Now we need to find for the ship Q. So ship Q is moving at, I'll put a star because I need this later. Right, for ship Q, first half an hour it's maintaining the same velocity, then only it's changing the velocity as towards north 15 km per hour. Right, so we'll find the velocity of Q at 12:30, then at 12:30 means t equals 0.5 hours, position vector of Q, that is Q is going to be, I'm going to use this equation, that this equation 42 minus 80I plus 9 plus 14t j, but t 0.5 hours substituted, 42 minus 8 into 0.5 I plus 9 plus 14 into 0.5 j, solve it, you will get 42 minus, you'll get 38, is it? Yeah, 38I plus that is 16j at 12:30 for Q. Right. Now after that, the Q is changing its velocity as 15 km per hour towards north. So we'll find out position vector after this at time t. We'll get it at general format, then we'll substitute the time. So after that, after 12:30, position vector of Q will become, 38I plus 16j. So that means you know the initial position plus velocity into time, is it? Plus velocity into time. That is 38I plus 16j. Initial position means at 12:30 this is the position. Constant velocity. What could be the new position due to this velocity means the position at particular known time plus velocity vector into time. Velocity vector, we know that velocity vector is 15j because they are saying it's moving at 15 km per hour towards north. North means j. So plus 15 t j. So it's going to be 38I plus 16 plus 15t j. This is the position vector of Q after 12:30 at any time t. After 12:30 at time t. Okay. Right. So the question is about 14:30. So how much, what will be the time? So at 14:30 means for Q the time will be another 2 hours because this is at time t after 12:30. So from 12:30 to 2:30 p.m. means 2 hours. What will be the position vector? That's going to be 38I plus 16 plus 15 into 2j. So that will be 38i plus 46j. Okay, that's the position vector of q. Okay, so I can say this is the position vector of q. I can put capital Q. Yeah, in a position vector, I will take OQ. OQ I can name. This is OP, right? Okay, at 14:30 for ship Q. Okay, if I put that in coordinates, if I put it in Cartesian coordinates, something like this, I, J. So for P, it's going to be 40I, 26J. Just remember, this is Q, 38I. So a little more, 38I. This is 38I, 46J. So this is Q, 38I plus 46J at time 2:30 p.m. But P, 40I, little more. So on the right side, little more on the right. I'll put it little larger. That's going to be 40I, 26J, little down. That is 40I plus 26J. So this is the position vector. This is the, we can call relative because their position vectors are changing. But this is the position of P and Q at time. So we need to find this distance. So to find this distance means we need to first find the magnitude. They ask you to find the magnitude of PQ vector. So this is O, this is OQ, this is OP. So we need to find either PQ or QP, whatever it is, no problem. And we need to find that vector, PQ or QP, whatever it is, no problem. Then we need to find the magnitude of that vector, that is the distance between P and Q, because they are giving the position vectors. To find the distance means we need to find the vector PQ or vector QP, either one. Then find the magnitude of that vector. That's all. That's the distance between the two ships at that distance. Okay, so we'll find the vector PQ or vector QP, whatever it is, both same, nothing different. Anyway, marks they are giving for this question little 7 marks, yeah. Right, so we'll find PQ, so or QP, whatever it is, doesn't matter because square, we are going to take the magnitude square, Pythagoras theorem. So even whether PQ or QP, the same answer. So we'll see the vector QP, QO plus OP, that is minus OQ plus OP. So OQ, that is minus OQ means minus 38I plus 46J plus OP 40I plus 26J. So that's going to solve it. You will get 2I minus 2I minus minus 46 plus 26 minus 20J. Okay, minus 38 plus 40, 2I minus 46 plus 26 minus 20J. Okay, so this is the QP position, this is the vector QP. So the distance between the two ships at that time is modulus of QP, that's the distance, that is square root of 2 squared plus 20 squared. So find that, that will be square root of 404, that is kilometer. You will get 20.1 kilometer. Okay, question 7 is about motion of an object on an inclined plane. So when an object is kept on an inclined plane, the component of the weights, if it is the object here, its weight will act vertically down, mg. This is alpha, so this is 90 degree, this is 90 minus alpha. So the component of the weight along the plane, we can resolve the weight along the plane, that's going to be mg cos 90 minus alpha. This is 90 minus alpha. So component of the weight along the plane will be mg cos 90 minus alpha. So cos 90 minus alpha, mg sin alpha. Remember that, mg sin alpha. That's the component of the weight along the plane down. Component of the weight perpendicular to the surface is mg sin 90 minus alpha, that is mg cos alpha. The normal reaction will act perpendicular to the slope, so the normal reaction will be along this direction is the normal reaction. Now it could slide down, or if you pull it, it will move up. So the motion will be always along the plane, means there is no resultant force perpendicular to the slope. So if I consider the perpendicular to the slope, so along the slope, so there is no motion perpendicular to the slope. So if you consider perpendicular to the slope, there is no resultant force, therefore along this direction. So the mg I don't need to consider, because now I have resolved the mg along the plane perpendicular to the plane, so I can remove that. So only two forces are there, r and mg. So r minus mg cos alpha must be equal to 0, because no motion perpendicular to the slope. So the normal reaction r equal mg cos alpha. So if there is a friction when you are pulling it up or down, the friction will be opposite to the direction of motion, but we know that F equal, the friction equal F equal mu r. So that could be mu, instead of r you can say mu mg cos alpha. Remember these things. The mg sin alpha, mg cos alpha, remember that it never changes. With the angle alpha, the component of the weights are mg sin alpha, mg cos alpha. R equal mg cos alpha, that also easy to remember, because perpendicular to the plane there are no displacement, no motion. Therefore, the friction is F equal mu r, mu mg cos alpha. Remember this, easy. When you do more and more questions, you will remember that. Yeah. Okay, so here, based on that, there's a question. The question says, box figure 4 shows block A of mass m held at rest on a rough plane. The plane is inclined at an angle alpha to the horizontal, and the coefficient of friction between the plane and the box is given mu. One end of the light inextensible string, so it won't, the tension will be the same everywhere, inextensible. The inextensible string is now attached to A. The string passes over a small smooth pulley, no friction for the pulley, which is fixed at the top of the plane. The other end of the string is attached to block B of the mass. The mass of the block B is given Km. Okay, the string from A to pulley lies along the line of greater slope, and the tension also given 4 mg over 3. Mu also given, tan alpha all are given. Find the magnitude of the acceleration. Okay, so not a big issue. So we'll consider the forces acting on the object A. Okay, so this is alpha. How many forces are acting on it? As I showed here, there will be a component of the weight acting this way, mg sin alpha, and it's moving upward direction. It says A moves up, means the friction will act down. The friction will act down. So Fr, friction is acting downward direction. So the normal reaction will be this direction R. The component of the weight will be this way, mg cos alpha. And there will be tension pulling the object upward. So if I draw the forces acting on B, if I draw for the B, weight of the B is K mg and there will be tension acting upward direction. So on the pulley there will be tension this way and this way, because object is pulling the pulley down. Here this is pulling it. So these are the forces acting on the string which passing over the pulley. These are the forces acting on the A and B. Careful, the tensions what I mark here, this is the force acting on upward, acting on B upward direction, B upward direction. On the string here, if I'll better put that here. 1 minute. So the tension acting on B is this way. The string is pulling it. The string is pulling the B, so string will pull the pulley also down. So on the pulley, the force is this way. Right, okay, so the question is find the tension, acceleration, is it? So we'll move it along the slope. We'll use the equation F equal ma. That is T for A, I use it for A, T minus mg sine alpha minus, because I'm using upward direction along the plane up. So T is up, T. Weight is down, so opposite minus mg. Friction also down, minus Fr equal ma. For the object A, I'm writing it. Okay, so we need to find the angles. So in the question it's given sine alpha, tan alpha given, tan alpha 7/24. So like 7/24, 7/24. Use Pythagoras theorem and find the length of this side. You will get 25. So sine alpha means 7/25. Cos alpha 24/25. Right. Okay. So here the tension is given 4 mg by 3. So Fr equal mu1. Again I write it, T minus mg sine alpha minus Fr equal mu1, because it started moving. So limiting friction is passed, so it's moving that value. So friction should be limiting friction. Mu r is equal to ma, but r is equal to mg cos alpha, because if you resolve it this direction, I already told that when I explained it, I told there is no motion perpendicular to the slope, means remember that r equal mg cos alpha. Now substitute the values. So T is given 4 mg/3 minus mg sine alpha. Sine alpha we know that 7/25 minus mu is given 1/3. R equal mg cos alpha, mg cos alpha. R equal mg cos alpha. So mu 1/3, R equal mg cos alpha. Cos alpha is 24/25 equal ma. So m. Okay, solve it. This is going to be 4 mg/3 minus 7 mg/25 minus, this is going to be 8 mg/25 equal ma. So continue, 4 mg/3 minus 15 mg/25 ma. All them can get cancelled, so this could be written as 3 mg/5, is it? So 4 mg/3 minus 3 mg/5 equal ma. Solve it, all them will get cancelled. LCM take it as 15 and solve it. You will get A is equal to M will get as 11g over 15. That's the acceleration. Okay. That's the first part answer. A part, first part. Okay, A part, second part, find the value of K. So the mass of B is Km, they are telling. Find the mass of, that's a value of K they are asking. A part, second part. So now it's an inelastic string. Inelastic string means the distance, whatever the distance A moves, B should move. So both should have the same velocity, both should have the same acceleration. So when you think about B, the acceleration should be the same. How many forces acting on B? If I draw the B again, how many forces acting? Its weight is acting K mg and there is tension T. That's all. These are the two forces acting. Its acceleration should be the same. So now write for B downwards F equal to A. F is Kmg minus T. These are the two forces. Kmg downwards, T upwards. It's accelerating down with the same acceleration because inelastic string. Inelastic string means whatever the distance it moves, it should move. Same velocity, same acceleration, right? Is equal to Km. K I can substitute 11g over 50. Tension is given 4mg over 3. So K mg minus 4mg over 3 equal K 11, we can say 11 K mg over 11 K mg over 15. Okay, so all the mg will get cancelled. Finally remaining will be K minus 4 by 3 is equal to 11 over 15. Yeah. Find the K. Take it to the right side. So it will LCM, if I take 15, it will be 20. 20 plus, I think, so the K is missing here, 11K mg would take a K, right? Okay, so that means K minus 11K over 15 equal 4 by 3. We solve it. 15K minus 11K, 4K over 15. Solve it anyway. That's a big issue. You'll get K is equal to 5. Okay, so the last part, B part, find the magnitude of the resultant force exerted on the pulley by the string. Giving you answer in terms of M and G. Okay, so if I draw the pulley, that is the pulley, I draw like a small thing. It has a force acting down. I told that this tension is the tension here. Tension, we know the tension that is given. Tension is equal to, given in the question, 4 mg over 3. And this one, because the string is pulling the object up, object will pulling it. So there is a tension here also, this way. So both are the same magnitude of force acting on the pulley. We can take a pulley like a negligible dimension. So the angle between these two is this angle, because here this is alpha. The angle between these two forces is same as this angle, is it? So that we can take beta. So alpha we know, sine alpha, sine beta. So this beta means sine beta, cos beta, anything we can find it. Because this is alpha, here alpha. This is 90 degree, this is 90. So between these two, this is the angle, this angle is beta. So beta, from this triangle, I can find the angle, sine or cos or whatever I want, I can find it. Okay, how to find the resultant force? So simple question, these are two forces. So if there are two forces, simply we do in physics, whatever the method you can do, resolve the both. This is a vertical force, this is force at an angle beta. So here from this I can say sine beta equal sine beta, opposite, 24 over 25. cos beta equals 7 over 25, right? So we'll resolve the first method. We can do in different methods. So first method, I'll put like a first method. Resolve all the forces horizontally and vertically. Simple. There are two forces. We know the tension both given. This is vertical. This is at an angle beta. I know the sine beta, cos beta. So this is vertical. Resolve it vertically. So downwards, if I consider t plus t cos beta. So that I can name it downward direction. Y is it? Y downward direction. So that is going to be t. We know that tension is given. We can substitute the tension later. So t plus t into cos beta 7 over 25. Okay, we'll substitute the values of t. So it's going to be 4 mg over 3 plus 4 mg over 3 into 7 over 25. Okay, so solve that one. It will be 128 mg over 75. 128 mg over 75. We solve it horizontally. This is a vertical force which has no horizontal. It's only x. That is going to be t sine beta. That is t is 4 mg over 3. Sine beta 24 over 25. Okay, so it's going to be 96 mg over 24 into 4, 96 mg over 75. That is x. Okay, so we know the vertical and horizontal component. Resultant force is equal to x squared plus y squared, is it? Pythagoras theorem, because this is a horizontal vector, this is a vertical vector. Resultant means Pythagoras theorem. Solve it. That is 128 mg over 75 all things squared plus 96 mg over 75 all things squared. So m squared g squared we can take it out. So 128 squared over 75 squared plus 96 squared over 75 squared, and take square root of it. You will end up with r is equal to, solve it, r is equal to 32 mg over 50. That's the resultant. You will get it. M squared g squared, then you take square root, it will become g. So only thing, 12 squared over 75 squared, 96 squared over 75 squared. You have to solve that and take square root of it. That is method 1. This way also you can do. There's method 2. Okay, so this method 1. Method 2, the idea is, since the two forces are same, the resultant will be along the bisector of this angle. The result is going to be along the bisector, because both forces are same means the resultant will be along the bisector of this angle. So this is beta means this is going to be cos beta by, this is beta by 2, this is also beta by 2, right? So the resultant will be along this way. When you resolve them perpendicular, I'll show that again. Since the forces are the same, imagine this is the pulley, this is vertically acting T, this is acting at an angle T, this angle is beta. So the resultant will be along the bisector of this angle. The reason is along this way. Because take this line, this is beta by 2, this is also beta by 2 if I take it. If I resolve both along this line, the bisector, this line, it will be t cos beta by 2, t cos beta by 2, 2t cos beta by 2 is the resultant. So resolve it perpendicular to this line. We can resolve a vector. Now I am taking the angle beta by 2 with this line. If I resolve this one perpendicular, means if this is the blue color line, the perpendicular component will be t sine beta by 2. This direction, t sine beta by 2. This if I resolve it, t sine beta by 2, that also perpendicular to the bisector line, is it? So t sine beta by 2, t sine beta by 2, both are perpendicular to the blue color line which I used to show the bisector. So they will get cancelled. The component along this way will be, along this way is going to be, along the line that gives the bisector, that's going to be t cos b beta by 2 plus t cos beta by 2. So they cancel each other. So result is going to be 2t cos beta by 2. Okay. But we know the cos beta. Cos beta by 2 is coming. How to solve it? Now we need the trigonometric. We know the trigonometric identities. Cos A plus B is equal to, we know that. It's given in a booklet. Cos A plus B is equal to cos A cos B minus sin A sin B. So if I take cos beta, A is equal to B means that is cos, you know that cos 2A is equal to, A equal to B means cos A cos squared A minus sin squared A. But you know that sin squared A plus cos squared A equal 1, sin squared theta plus cos squared theta 1. So instead of sin squared A, I can write cos squared A minus 1 minus cos squared A. That's going to be 2 cos squared A minus, that is cos 2A. So any angle here, it's half with the square comes minus 1. So I can consider cos half, this angle's half here comes. So that means I can consider 2 cos squared beta by 2 minus 1. 2 cos squared beta by 2 minus 1 is cos beta. Double, it's double. So beta by 2 double beta. Okay, so I can find, I need the cos beta by 2 resultant. In physics is okay, but we need more trigonometry here. So cos squared beta by 2. So then we can say, bring this left. So I can find cos squared beta by 2 equal 1 plus cos beta over, this 2 comes over 2. Okay, so cos beta by 2, I can find it from that. Okay, I'll continue here. Okay, so correct now, 2 cos square beta by 2. Yeah, take it 1 plus cos beta, the 2 comes down, right? So cos beta by 2 equal square root of 1 plus cos beta over 2. Okay, so I raised it. We know that cos beta, we found that already, that is 7 over 25. So that is going to be 1 plus cos beta 7 over 25 over 2 square root. So it's going to be 25 plus 7, 32 over 50. Anyway, 2 and 32 will become 60. So it's going to be square root of 25 LCM. 25 plus 7, 32. 32 over 2 into 25. So 32 divided by 2 is 16 over 25. So it's going to be, cos beta by it is going to be square root of 4 over 5. So substitute here. Resultant is going to be R equal 2t, 2 times, t is given as 4 mg over 3 or something. 4 mg over 3. Four mg over 3 into cos beta by 2. I found the cos beta by 2, 4 over 5. How much is it? So it's going to be, 16 into 2, 32 over 15. Right, correct, no? 32 mg over 15. Same answer I got in the first method. Check it. First method also I got 32 mg. I'll write it here. It looks like cube. Same answer I got there. 32 mg over 15. That's the same answer I got in the first method also. Only thing, physics easy. Beyond that, maths you have to do a little bit. Anyway, you know, you can remember this. I just showed it. but you can use this one directly. The identities are given in the data sheet, equation sheet, booklet. Okay, the third method, if you like, you can use the cosine rule also. You'll get the same answer. Try it that way. The resultant force R squared is equal to T squared plus T squared plus, because it's an acute angle, right? Find it, it's an acute angle, plus 2T into T cos beta. Okay, use this way, you will get the answer, acute angle. So if it is acute angle, you have to use the plus here. So solve it, you will get the same answer here also. That is 4mg over 3 all in square plus 4mg over 3 all in square plus 2 times 4mg over 3 into 4mg over 3 into cos beta 7 over 25. So you'll end up with m squared g squared into 1024 over 225. So R will be equal to 32 mg over. Same answer, you get it. Okay. Okay, I hope you understood it's useful. Yeah. Okay, right. Bye.